is not always simple. Does that make sense? So be aware of that. Let's look at this. So we have the sum of 1 over k squared here, and the sum of 1 over k squared plus 10 here. In this case here, the denominator is going to be larger than the denominator up there for any given k, correct? Because we're adding 10 to the denominator down here. That make sense? So based on what we just talked about over here, if this denominator is larger, then the value of this fraction is less than the value of that fraction. Do you agree? And for all positive k, that's going to be the case, isn't it? The value, when you put 5 in for these k's, this one is going to have a value less than that one. Notice the graphs. This is 1 over k squared. This is 1 over k squared plus 10. The p-series test tells us this 1 over k squared does what? Diverges or converges? Converges. It tells us that right there by p-series, right? We cannot apply the p-series to this one because of the plus 10. Does that make sense? We cannot apply it. But
we can see it.
we know that this one is always less than that one, don't we? And it's always positive. We know that that one converges by the p-series test. Well, if this one is always less, doesn't it have to converge too then? There's no chance it's going to shoot up to infinity, is it? Is there? If it's always less than that? You see what I'm saying? Because of the plus 10 in the denominator, this is always less than that. We know that converges by the p-series test. P is 2. That's greater than 1. If that converges, this stays positive and always is less than that, this has to converge too. It cannot shoot up to infinity if it's always less than this. Does that make sense? That logic we just talked about proves that this converges by comparison to this. What this says. This is the comparison test. A sub k, that's a given series that you're trying to prove convergence for. B sub k is going to be one that you think of, you come up with. Let A sub k and B sub k be series with positive terms. They're positive. It will never dip negative. If A sub k is less than or equal to B sub k and B sub k converges, then A sub k converges. That is exactly what we just talked about here. This is your A sub k. It is always less than or equal to B sub k. B sub k converges, therefore this has to converge. That is what number 1 here is saying. Does that make sense? You hear the logic in it? Look at this situation. 1 over square root k. Square root is like k to the 1/2, correct? 1 over k to the 1/2. What does the p-series test tell us there?
Less than 1, then it's divergent.
Yes. If p is less than 1, it diverges. Again, this is like k to the 1/2, so p is 1/2. That's less than 1, therefore this has to diverge. Here, we're subtracting 3 from this k down here. So in this case, the denominator is always less than this denominator. It's always 3 less. When the denominator is smaller, the fraction is bigger. So this is always bigger than this, isn't it? If this diverges, and that is always bigger than this, above it, then that has to diverge, doesn't it? You hear that? That's what number 2 is saying. If B sub k is less than or equal to A sub k, and B sub k diverges, so B sub k is the one that's down below, less than, and it diverges, A sub k is always above it. If this one's going to diverge, that A sub k also has to diverge. It's getting pushed up there. Does that make sense? That's what number 2 here is saying. And this is what we're talking about with the comparison test. All right. Let's look at an example of this. What's my example? K to the third over 2k to the fourth minus 1. So we got the sum. I'm going to pull up the screen here in a second. K equals 1 to infinity, k cubed over 2k to the fourth minus 1. Okay, first off, just look at that. We're going to need to get good at just through our intuition looking at it thinking that's going to diverge or that's going to converge. We need to develop our ability to get a hunch about what it's going to do. Does that make sense? And then we need to attempt to prove that. Does anybody have a hunch about this? Do you think it'll converge or diverge? You think it's going to diverge? Any reason why? It's a good hunch.
Because the k to plus 3 is more bigger than the 2k to the fourth.
More bigger?
Yeah, something like
What's the difference in degree here? Degree 3, degree 4? 1. This is 1 over k to the 1. Anytime you have, this, forget about the 2 and the negative 1, this k cubed could cancel into the k to the fourth and give us 1 over k, right? So that's going to behave for very large values of k. It's going to behave similarly to this, isn't it? Right? And this we know diverges. So there's a good likelihood that will diverge. Let me get my thought here together. Okay. So k cubed over 2k to the fourth minus 1, I'm going to write it this way, behaves like k cubed over 2k to the fourth for large values of k. So let's take a look at the sum as k goes from 1 to infinity of k cubed over 2k to the fourth. Well, the k cubed can reduce with that k to the fourth and give us 1 over 2k. we can factor out the 1/2. And this, the harmonic series, we know diverges. The test that says it diverges is the p-series test. If p is greater than or equal to 1, it diverges. P is the exponent on the k here, and it is 1. And this diverges by the p-series test. All right. Notice that k cubed over 2k to the 4th minus 1 is greater than k cubed over 2k to the 4th. Because of the minus 1, that makes the denominator less than that denominator. And when the denominator is less, the fraction is greater. Does that make sense? So because this is greater than this, which equals 1 over 2k, this implies, that symbol means implies. I'll write the word above it. This implies that the sum as k equals 1 to infinity of k cubed over 2k to the 4th minus 1 diverges by the comparison test. So again, this expression in our given series is for k greater than or equal to 1 is always greater than this expression, which equals this, which right here we know diverges by p-series. So if this diverges and this is always greater than that, this has to diverge by comparison. Does this make sense? So when you do these, the two key statements, if you're going to prove divergence, you have to show this. I'm not going to make you prove it, okay? But you have to show that the one we're given is greater than the one you're comparing with. You have to state it. And then this entire line here you have to show. You need to tell why this one diverges, and this is the statement here. So maybe I should do this. This and this, I need to see those two things. You need to show why the one you're using for comparison, why it diverges or converges if that's the case. And then you need to show this logic here, diverges by comparison test. Any questions there? There's supposed to be an E on the end of like. All right. Let me find one here for you to do.